everyone, this side Arohi from Piper Technologies, and today I'll talk about multinomial naive Bayes. So multinomial naive Bayes comes under supervised learning and it is a classification algorithm. With the help of multinomial naive Bayes, we can do text classification. So text classification simply means you have data in the form of document, post or messages, right? And our task is to tell whether that particular message or post is belong to which particular class. For example, sentiment analysis, right? In sentiment analysis, suppose you have data of Twitter and you want to perform sentiment analysis. That simply means you want to know whether the particular review, whether the particular post user is posting, whether that review is a positive review, negative review, or a neutral review, right? So this kind of task we can do with the help of multinomial naive Bayes. So for my today's class, the data which I'm using is this data. So I have one data, samplenews.csv data, right? So what we have in this data set is we have two columns. One is title and other one is category. Title is sort of message, means it is a heading of news, right? So this is a news. In title column we have a news, and in category column we have the related class, means the first title, the first news belongs to B class. So B stands for business, right? So we have three kind of classes in this data set. So B is for business, and we have one class with the name of T means technology, and we have another class with the name of E means entertainment. So means in this data set we have two columns, title and category. On the basis of title we need to tell which this particular title belongs to which particular category, right? So let's check the shape of our data set. So in this data we have 77 rows and two columns, right? Two columns, title and category column. So now over here I'm performing a value count on category column, on this column, right? Why I'm performing value count on this? Because I just wanted to know, like, for a particular class how many records we were having. So for business class there were 31 news belongs to business class, 24 news belongs to entertainment class, and 22 news belongs to this technology class. So if we want to perform text classification on this, so there are a few basics which you need to know before moving to multinomial naive Bayes, right? So we'll be discussing those basics first. So NLP simply means natural language processing. So I'll be discussing three or four topics over here which are required for today's class, right? So first of all, if you have installed NLTK in your PC, that's good. But if you don't have this particular module, so you need to install it, right? After installing it, I'm explaining you the concept of NLP by using a single sentence. Then we'll later on in today's class only we'll be implementing this NLTK, this NLP on whole data set, right? So for now, in data variable I have this sentence, okay? So whenever you want to perform multinomial naive Bayes, first of all we need to divide our data, we need to divide our sentence into words. So that's what I'm doing over here. So over here I have imported word underscore tokenize module from NLTK. Word tokenize, as it is clear from name only, it will divide your sentence into words. It will tokenize the sentence into words. So see, this kind of output you'll get. So earlier we have one sentence, but after performing word tokenize on it, we have data like this. Pipeford, that whole line gets splitted into words, right? So this is what word tokenize does. So now there is one more thing which you need to understand, it that is stop words. See, stop words are nothing but it's just like a connecting words. It connects your line, right? For example, see, these are the stop words over here. So in every language there are different stop words. So our data set is in English, so that's why we are using stop words of English only. So we can import stop words from nltk.corpus. So I'm importing stop words first of all, and then in stop words variable I am setting all the stop words, and when you'll print it, so you'll get this output. So these are the different stop words which present in English. So what are the stop words? It, the, any, and, are, these are stop words. These are just connecting words, right? So the next task is, after dividing your data into words, next task is to delete all the stop words. For example, in this line only, is, these are stop words, right? These are not necessary, these are not required when you want to know whether this particular line belongs to which particular class. So for that, these words are not important, so we'll be deleting such words. So this is what stop word does over here. And then, okay, now the next thing is we want to perform text cleaning. See, before applying multinomial naive Bayes, we need to clean our messages. The same way as we always clean our data, and after cleaning our data, we perform algorithm on it. In the same way, if you want to perform text classification, if you want to perform multinomial naive Bayes, so we need to clean our messages first of all. So in messages, we have punctuation also. So what is punctuation? Punctuation simply means this apostrophe s, this comma, this exclamation symbol, this full stop. These all are punctuations. So we need to delete such things also from our data. So how we can delete this punctuation? So for that, you can simply use this string module, right? String module. So string module have a capability, it have a functionality by which we can remove all the punctuation. So I'll show you how to do this. So for that, for this particular functionality, I'm working on this sentence, right? In data variable, I have this sentence, and we know like this apostrophe and this comma, this exclamation, and this full stop. These all are punctuation, and we want to delete this. So how we can delete this? So what I'm doing is I'm using a loop, and I'm using string dot punctuation. String module have this punctuation function, so we are implementing that function on and we want to implement it on this particular data, right? On data. So for char in data, and if char not in string dot punctuation, it simply means if the data which is present in data variable not belong to punctuation, then that data should get stored in this, right? So after printing it, so we are getting this kind of output. So over here you'll see our whole sentence get divided into alphabets, but we don't want data like this, right? We want to tokenize the data, but we want to tokenize this sentence into words. We don't want to tokenize words into alphabets, right? So after performing this, we need to join the words, right? So I'm performing join. This is a string function, right? Normal string function. So I'm using it, and then print the output. So this is what you'll get. Now compare this sentence with the original sentence. See over here, apostrophe, comma, exclamation, and full stop. All those things are deleted now. So we have performed punctuation successfully. Now, after performing punctuation and after joining the words, we have a whole line like this. Now our next task is to divide this sentence into a tokens, into a separate words. Remember, I've told you, like whenever you want to work on multinomial naive Bayes, you need to divide your sentences into a words. So that's what I'm using over here. See, you can use split method directly also. This is again a function of string, or you can use word underscore tokenize of NLTK module. So I'm using split over here, and then after that when I'm printing, so this is the output what I'm getting. So our whole line get divided into tokens, our whole line get divided into words now. So see this, now this is what we want on this data. We, okay, now the next thing is um, we all know, like in this machine learning, our machines, our algorithms understand only numbers, but our data is in words now, right? So our next task is to convert these words into numbers. And you all have studied label encoding, right? So label encoding simply means when you want to convert words into numbers. But over here, we cannot apply that label encoding. Why? Because we can perform label encoding when we have only one word in a column. But over here, we have multiple words in a column, because what we are doing over here is text classification on the basis of messages or post, and in one single message we are going to have multiple words, right? So for every different word we want one separate numeric number, so that cannot be done with the help of label encoding. So for that we will be using count vectorizer, right? So now let me show you the functionality of count vectorizer. So this is the sentence on which I'm performing count vectorizer. So in data underscore one variable, I have this sentence, right? So first of all, I'm importing count vectorizer, and then I'm calling this count vectorizer in a vectorizer variable, and then I'm fitting the data in it. So whenever we use any algorithm, first of all we fit the data and then we transform, or then we predict the data, right? So the very first thing is to fit the data on which we want to perform the functionality. So on which data I want to perform the functionality? The data which is present in data underscore one. So once you fit the data into a count vectorizer, you can use this vocabulary underscore method. This will tell you which numeric value is assigned to which particular word. So how many different words we have in this data? Pfeiffer Technologies is in Mohali. So these are the different words. So 3 numeric is assigned to Pfeiffer, 4 is assigned to technologies, 1 is assigned to S, 0 is assigned to N, and 2 is assigned to Mohali. Means 3, 4, 1, 0 and 2 are the numerics which are assigned to these different words. So this is how you can use count vectorizer. Now till now I've just fit the data. We hadn't transformed our results. So over here I'm performing dot transform on what? On our data one variable only, right? So this is how this kind of output we get. So this zero, what this zero is, we have single sentence over here and index always start from zero. So this zero simply means zeroth row, the very first row. This 0, 1, 2, 3, 4 simply means in zeroth row, the word which is encoded as 0, which word is encoded as 0? In present only one time. This is the count, how many times which particular word is occurring. So in zeroth row, the word which is encoded as 1, which word is encoded as 1? Is occurred only once. In the same way, the word which is encoded at 3 occurred twice. Which word is encoded as 3? Pyford. Pyford is occurring twice. See the data over here. So Pyford is occurring 2 times now. So this is giving us the count of that. So these are the basics which are required whenever you want to perform multinomial naive Bayes, right? So the things which I've just discussed with you, I'm putting all those things in one function. I have created one function with the name of text cleaning. Now see, I've done with the basics. Now we are again going to work on a data set only on which we are working, right? So text cleaning function I've created. So in this text cleaning function, first of all, what I'm doing is deleting all the punctuation. And then we are joining the data, and then we are splitting the sentence into words. This is what we did earlier, right? So all this functionality I've stored in this text cleaning function, right? So over here, I'm showing you the original data. So this is the original data, right, on which we are working. And now, see, this is the output. There is no need to work on this column. So our main target is this title column. We need to perform data pre-processing on this column so that we can make this data ready so that we can perform multinomial naive Bayes on it, right? So this is a zeroth column, title is a zeroth column, and category is a first column. So df.ilog zeroth column dot apply text cleaning. Apply is a method. By using this apply method, you can apply any function over here. The function which I've created is text cleaning, if you remember, text cleaning, right? So what I'm doing over here is, on this zeroth column, I want to remove all the punctuation, and then I want to divide the whole sentence into words, right? So this is the output you'll get. So this is the original sentence, and the sentence get divided into separate words over here, right? Now the next thing is to convert these words into a number. So for that we need to use count vectorizer. So that's what I've done over here. I've used count vectorizer, and in this count vectorizer, which data we need to give to this count vectorizer? Df title column, right? So you will see over here, as I've told you a few minutes back only, by using this vocabulary underscore, you can get to know like which particular alphabet, which particular number is assigned to which particular word. So this is the detail of that. So now I'm transforming the whole data, right, of our data set. Our data set is in df. Df is the data set, and title column is the column where we have all the news, right? So I'm transforming the data. So this is how it looks like. See, over here you can see this much. Let's discuss this much only. Zero. This zero means the very first row. In our very first row, in our very first message, we have these words, these are the words, right, which are encoded into numbers, and these words are occurring only one time. And then we are talking about next row, 1. So in next row, these are the numbers which are, these are the words which are encoded as number, and these words are occurring only one time. So this is how our data got converted, and we are having data till 76. Why? Because according we have total 77 records in our data set, right? So over here you can see, if you want to know, so we have checked the shape of our data. We have 77 records, right? So after that, the next task is now we need to find out in one row, means in every particular message, which word is more important. On the basis of that word only, we will be finally classifying the data. Suppose if a sentence is, the movie is a good movie, right? Suppose this is a sentence, the movie is a good movie, this movie is a good movie, for example. So in this line we need to check which particular word is more important. This movie is a good movie, which word is more important, right? So on the basis of that particular word, we'll be finally classifying our output, right? We'll be classifying that this particular sentence belongs to which particular class. So for that we have TF-IDF transformer. See, with the help of TF-IDF, we can find out the most significant words. How to do that? Just import TF-IDF transformer, then fit data in it. After fitting the data, transform the results, right? So, see, this is the output. See, for every row, for first row, in first row, these are the different words we have, and these are the different TF-IDF value. The word which have more TF-IDF, highest TF-IDF value, will be a more significant word in a sentence. So let's talk about the very first row. In the very first row, which word is more important? See, this word is having this value, this word is having again this value. So, okay, so this is the word which have least importance in this sentence. and the word which will be having the higher number will be more significant number. So in the same way, we have performed this TF-IDF for all the rows, just to know, like in every sentence, in every message, in every title, which particular word is more important, right? So we have performed TF-IDF on it. Now we can perform multinomial naive Bayes. So for that, you simply need to import multinomial naive Bayes from sklearn.naive Bayes and then fit your data in it. So this is the column title TF-IDF. These are the news, right? And DF category is the value. This is Y. So we have fit the data in it, and then we are predicting the output, right? And these are the different predictions. Now let's see the difference. Now let's see the basically I'm plotting a confusion matrix over here. I just wanted to know, like, what are algorithm predicted and what are the actual outputs over there. Means I want to know the difference between the actual values and the predicted values. So that's why I have plotted, I have a confusion matrix over here. So if you'll see over here, all the classes are correctly classified, right? Means we don't have any false positives and false negatives over here. We have all the true positive values for the respective classes. So that means our algorithm and our actual values are same. So what we have studied today is multinomial naive Bayes, and whenever you want to perform multinomial naive Bayes, what you need to do is you need to perform text cleaning. First of all, text cleaning simply means you need to delete stop words, and then you, after removing stop words, you have to delete punctuation. After punctuation, we need to split our sentences into words, and once your sentences gets divided into words, you need to convert those words into numbers. And once you convert your words into numbers, then we'll finally see which particular word is more important, more significant, and then you perform multinomial naive Bayes on it, right? So thank you for today.